Hello everyone, let's solve question 28 of GATE paper CS1 2025. A regular expression L is accepted by non-deterministic finite automation NFA with n states. Which of the following statement is or false? In order to understand this question, we need to understand its prerequisites. So let's go into that and understand deterministic and non-deterministic languages. So uh, what we need to see here is let's understand what is the topic. So we are talking about regular languages. Let's understand that. So there are two types of these machines. One is NFA and DF. Another is DF. NFA is basically non-deterministic finite automation. Okay. What we are talking about? We are talking about regular languages that can be accepted by simple machines called automata. Okay. There are two types of these machines. हम ऐसी लैंग्वेजेस की बात कर रहे हैं जो मशीन से एक्सेप्ट हो सके ऑटोमेटा मशीन से ऐसी दो प्रकार की होती है देयर आर टू काइंड्स ऑफ दैट वन इज एनएफए व्हिच इज नॉन डिटरमिनिस्टिक finite automation another is DFA deterministic finite automation they do the same job they accept or reject the string but the working is different how let's understand in DFA every state and every input symbol, for every state and input symbol, there is one path. For NFA, there are many paths or even more. That's the only difference. Difference between NFA and DFA is this. DFA for every state and every symbol, one path. For NFA, for every state and every symbol, multiple paths. Any language accepted by NFA can be accepted by DFA, but uh, converting an NFA to DFA may increase the number of states. Now, how many states it can increase? If NFA has n states, DFA can end up with 2 to the power n states. This is the worst possible scenario. Let's understand the possible options. L may be accepted NFA with less than n state. Is it possible that someone can write a smaller NFA for same language? Yes, it is possible. Uh, so what we need to figure out? Now, this is possible. This statement is true basically. It is possible that NFA can have n state and you might not be the smallest one. Maybe someone else can design the fewer states. Possible. L may be accepting DFA with n states. Can DFA have fewer states than the original NFA? The option B means this that whether a DFA can have fewer states than NFA, it's possible. Uh, it can happen. Option C. There exists a DFA with less than 2 to the power n state that accept L. Is there a DFA that has at most 2 to the power n states of a language? Yes, this is guaranteed when converting an NFA to a DFA. This is a very famous result. This statement is true, not a false. Every DFA except a language with greater than 2 to the power n states. The meaning of this particular option is it necessary that all DFAs of L must have more than 2 to the power n states? No, this is wrong. 2 to the power n is the maximum, not the minimum. So most DFAs have way lesser states than this. So this is a false statement. So on option D is false, and that's what question asked for. What does the question ask? The question asked me that which of the following statement is false. So option A, option B, and option C are true. Option D is false. That's it for this particular video. Take care. Bye bye. See you guys in the next video.